Okay, so today we have exponential and trigonometric functions. So we will study how do we deal with this type of functions. We have exercise 12E, and the concept will remain same as we discussed before for exercise 12A, B, E, and D, right? So basically, consider particle moving. So its position at time t is given by the question r equals to r cos omega t. This is the horizontal component, and vertical is r and omega t, where r and omega are constant. Okay, so so if you look at question number one, you can see the question one exercise tell a particle moves that its velocity of time t is given by v equals to 2 times e is raised to power 2t, and e is raised to power 2t plus 2. At time t equals to 0, the particle is at 0, 0 means origin. Find an expression for the particle's acceleration at time t, and we find an expression for the particle's displacement. So this is the velocity. So when we have to find out acceleration, we know we will have to derive. We have to find the derivative of the velocity that will give us the mm, acceleration. Okay, and for the displacement, you will integrate the velocity. Right, same the procedure, the concept which we are following from the exercise 12a. So we'll continue with this one, and let's solve it. So this is the velocity. We have to find out acceleration. Okay, we have to find out acceleration. So acceleration a equals to dv over dt. Differentiate this one first. This is 2 times that is its derivative is 2t. Its derivative of 2t is 2, and here is power 2t times 2, and the derivative of this 2 is 0 because constant, so it will be 4 is to e to the power 2t, and here 2 times e is raised to power 2t. So this is the acceleration, right? Now, now we have to find out, if we look at part b, we have to find out the displacement, right? So displacement is denoted by r initial, right? So r equals to, when we have to find out r, we will integrate v. R b will be the function of vt, right? You integrate the velocity, then you can get this one. So we know this is the v. So when we integrate this, so we will get the answer 2, right? E is to power 2t. Same here, it will be right 2 plus c1. You integrate this one. So e is raised to power 2t over 2, and this 2t plus c2. Okay, so this integration you already know, right? So I will not explain more about integration because these are the basic integration which you should know before doing this exercise. Okay, so e is to power 2t plus c1, and here e 1 over 2 is to power 2t plus 2t plus c2, right? This is the displacement, rt, displacement vector. Okay, this is what displacement vector. Now now if we look for the initial position, r0 equals to, so r0 means this will be e to the power 0 whole plus c1, here e to the power 0 plus 2 times 0 plus c2, and this should be equals to 0, 0 because this is the initial. So if you solve this one, we have 1 plus c1 equals to 0, and yes, 1 plus c1 equals, oh sorry, this is 1 over 2, right? Yeah, so this is 1 over 2 times 1, 0 plus c2 equals to 0. So from here c1 will be equals to negative 1, from here c2 will be negative half. right? So RT, then RT displacement vector will be e is to is power 2t minus 1, and here 1 over 2 e to the power 2t plus minus half. Okay, so this will be the displacement vector. Okay, guys. So when we have to find out, if you look at the question number 3, particle moves so that its acceleration is given by the expression a equals to 8 cos 2t and 8 sin 2t. Given the particle has initial velocity of v equals to 0 minus 4 and initial displacement of minus 20. Find an expression for the particle's displacement. Okay. So displacement we can get when we have a velocity, we will integrate the velocity, but here we have acceleration. So we'll do step by step. First, we find out the velocity. So Vt, V equals to, you integrate this acceleration. So when you integrate this acceleration, you will get, this is 8. Okay, integrate cos. Cos means this will be sine, right? Sine 2t, sine 2t, and here 2 plus c1. Here 8 sine means minus cos times minus cos 2t over 2 plus c1. If you simplify, you will get 4 sine 4 sine 2t and minus 4 cos 2t plus c1 and c2. Okay, c1 and c2 constant. C1 and c2. Right now, but we know v0 equals to v0. Let's initial. So v0 means 4 sine 0 plus c1 minus 4 cos 0 plus c2, and initial velocity 0 minus 4 is right. So sine 0 is 0. So from here c1 equals to 0 and cos 0 is 1, right? So minus 4 plus c2 equals to minus 4. So minus 4 cancels. C2 is also 0. So Vt will be we will have Vt will be 4 sine 2t, right? Minus 4 cos minus 4 cos 2t, right? Plus c1 c2 0. Now after getting this one, this is the velocity. Now we have to find out displacement. Displacement integrate the this one. So 4 sine means, right, you will integrate this one. So you will get minus 4 into minus cos 2t, cos 2t over 2, and here minus 4 sine 2t, sine 2t over 2, here plus c1 plus c2 constant. So this becomes minus 2 cos 2t minus 2 sine 2t plus c1 plus c2. Okay, again initial r0, initial displacement is given. So initial displacement means we'll put t equals to 0, 2 cos 0 plus c1 minus 2 sine 0 plus c2, and it is given initial is given minus 2. Yeah, it's given minus 2 and 0, right? So if you solve, you get c1 equals to 0, c2 also 0, right? So then r will be rt, displacement vector will be this one, minus 2 cos 2t minus 2 sine 2t. Okay, this uh, this will be. Now we have to find out then, this was the part A, and in part B, if we look at the part, right, part B is as okay. Part B, find the particle's distance from the origin. Okay, right. So this you can find out. It's so simple, right? Distance between 2 points you can find out. So part B, simply rt is the, yeah, it will be the position vector from the origin, since it is given in the question, the initial position at 0 0 means from the origin. So for part B, just looking for the magnitude of rt, so that you can find out this is minus, oh yes, you can find out this is minus 2 cos 2 whole square and plus minus 2 sine 2t whole square. So you can use this and then you can get the value of this. Right? Now after this one, so if you solve this one, you are getting this magnitude of r equals to 2, right? So this will be the distance from the origin. Okay. So since hence describe the path of the particle, right? So this is, since this is the distance from the origin, so it will be taken as a radius of the movement of particle. So you will say the particle moves, right? Particle moves, party moves. Okay, since this the thing is positive, anti-clockwise. Okay, anti-clockwise with radius 2, with radius 2 and center 0 0. Center 0 0 means origin. It's already given in the picture, right?